Hello and welcome to Algebra 1 Test Section 1 on using rational numbers as exponents. All right, so we're going to start out by looking at 32 raised to the power of negative 3/5. So what do I do when I have a negative exponent? Well, again, I take the reciprocal of the base. So the reciprocal of 32 is 1 over 32. And then I just make the exponent positive, so it becomes 3/5. Now at this point, you should know how to deal with the fractional exponents that we come across. So the numerator is going to stay as a 1, and then 32 raised to the 3/5 power. Again, 32 is going to be my radicand. Okay, going to be my radicand. Let me kind of make that arrow a little better. 5 is going to be my index, right? That's my denominator here. And this whole thing is going to be raised to the power of 3. So let me put equals, and I'll rewrite it because it's a little messy. We'll have 1 over the 5th root of 32, and then this whole thing is cubed. Okay, so what is the 5th root of 32? Just starting with this part right here. Well, that's equal to 2. So what I'd have is 1 over 2 cubed. Now we know that 2 cubed is 8, so I'd have 1 over 8. What about 243? Raised to the 6/5 power. So I would write this as the what? The fifth root of 243. And this whole thing is raised to the 6th power. Again, this becomes my radicand. This 5 is going to be my index. And the 6 is what I'm raising everything to. So the 5th root of 243 is 3. So this would be 3 to the 6th power, which is equal to 729. What about 16 to the power of 1/2? We should know at this point that raising something to the 1/2 power is like taking the square root, right? 16 would be your radicand, and your index would be a 2. So it would be the square root of 16, which is 4. Hello and welcome to Algebra 1 Test Section 2 on using rational numbers as exponents. All right, for the first one, we're going to look at 81 raised to the power of 3/2. And so what I want to do here is I want to take the square root of 81, and then I want to cube that result. This is going to be my radicand. This, the denominator, is going to be my index. In the case of a square root, you don't show the 2. And this 3 is going to be the exponent right there. So the square root of 81 is 9. And then if I cube 9, I'm going to get 729. What about 16 to the power of 3/2? Well, again, what I want to do is take the square root of 16, and then I want to cube that result. This is my radicand. 2 is going to be my index. Again, we don't show that for a square root. And this is going to be my exponent outside. So the square root of 16 is 4. You'd have 4 cubed, which is 64. All right, 4 times 4 is 16. 16 times 4 is 64. What about 10,000 to the 5/4 power? So we would set this up as the 4th root of 10,000. And we would raise this result to the 5th power. Again, this is the radicand, this is the index, and this is the exponent over here. So how would I figure out what the 4th root of 10,000 is? Well, we could factor it. I could start out with 10 times 1,000. And I'm not going to go any further. I'm not going to break this down to 5 times 2. Let me just break this down into 10 times 100. And then let's do 10 times 10. So that we can see that 10,000 is 1, 2, 3, 4 factors of 10. So this would be 10 and then raised to the 5th power. How do we do that quickly? We write a 1 and we follow it with 5 zeros. 1, 2, 3, 4, 5. And that's also how you could have figured out this one. You could say, well, if I had 10 to the 4th power, it would be a 1 followed by 1, 2, 3, 4 zeros. And I have 4 zeros here. 1, 2, 3, 4. So the 4th root of 10,000 is 10, right? But even if you can't remember things like that or use tricks like that very easily, you can go through and use a factor tree and figure out what the 4th root of 10,000 is. Now, once you do that, again, we get 10 to the 5th power, which is equal to 100,000. All right, for the last one, let's look at 27 to the 2/3 power. So again, I take the cube root of 27, and then I'd square the result, right? This is your radicand, this is your index, and then this is your exponent over here. And let me just make that a little better. So the cube root of 27 is 3, so you'd have 3 squared, and that is 9. Hello, and welcome to Algebra 1 Test Section 3 on using rational numbers as exponents. All right, so we're going to look at n to the 6th power, and this is raised to the power of a -3/2. So what I want to do here is just use my power to power rule to begin. N stays the same, and I'm going to multiply the exponents. So if I had 6 times -3/2, what's going to happen is the 6 would cancel with the 2 and give me a 3. So I'd have 3 times -3 or -9. So n to the power of -9 is what I'd have. And of course, we know how to do this. We take the reciprocal of n, that gives me 1 over n, and we make the exponent positive. So my final answer here would be 1 over n to the 9th power. What if I looked at x to the 16th power raised to the 3/4 power? Again, I want to keep x the same, and I want to multiply the exponent. So 16 times 3/4. Let me just fix this sign here. So what would happen here is the 16 would cancel with the 4 and give me a 4. 4 times 3 is 12. So this would be x to the 12th power. All right, for the last one, I'm going to look at 343b cubed, and this is raised to the 1/3 power. Be careful here. Remember, this is multiplication. So I'm going to use my power to power rule, and I'm going to remember that it's going to be 343 raised to the 1/3 power times b cubed raised to the 1/3 power. Now, all I do there is just multiply exponents. 3 times 1/3 is 1, right? The 3's would cancel. So what I'm going to end up with is just b. So let's rewrite this as the cube root of 343 times b. And what is the cube root of 343? Well, that's going to be 7. 7 times 7 is 49. 49 times 7 is 343. So this ends up being 7b as our answer. Hello, and welcome to Algebra 1 Test Section 4 on using rational numbers as exponents. So we're going to start out with, we have a b squared inside of parentheses, and this is all raised to the power of -1/2. Then we're multiplying by, we have b, then a to the power of 1/3 inside of parentheses, and this is all raised to the power of 3/2. So let's start out by using our power to power rule. So a is raised to the power of -1/2, so let's write that. A to the power of -1/2. Then times, we have b squared raised to the power of -1/2. So power to power rule, I have b, and then I'll multiply the exponents. 2 times -1/2. The 2's will cancel, and I'm left with -1. Let's erase this. Then times, doing the same thing over here, I'll have b raised to the power of 3/2. Then times, lastly, I have a, which is raised to the power of 1/3, and that's raised to the power of 3/2. So again, power to power rule tells us we keep a the same, and we multiply 1/3 times 3/2. So what I'm looking to do now is just cancel these 3's, and I'll be left with 1/2. All right, so now let's do some multiplication. If I have a to the power of -1/2, and I multiply by a to the power of 1/2, I keep a the same, and I add the exponents. -1/2 plus 1/2 is 0. A to the power of 0 is going to be 1. So I can write 1, or I can leave it off. For the sake of completeness, I'm just going to go ahead and write the number 1. Now next I have b to the power of -1, and I'm multiplying this by b to the power of 3/2. So b stays the same, and I'm going to add -1 plus 3/2. Now to get a common denominator going, I'm just going to write this as -2 over 2. And -2 plus 3 is 1, so this will be b to the power of 1 over 2, or b to the 1/2 power. So we can write this answer as b to the power of 1/2, or if we want to, we could just write what? The square root of b. Either answer would be acceptable, but as we move higher in math, we're typically going to report our answer in this format because it's just more compact, it's neat, it's cleaner. Okay, let's take a look at the next one. All right, so now we have x times y raised to the power of 1/3. This is multiplied by y squared, which is raised to the power of -2. So for this, I really can't do anything. I'm just going to write x times y to the power of 1/3. Nothing I can do with that at this point. I've got to deal with this first. So if I have y squared, and that's raised to the power of -2, leave y the same, and then go ahead and multiply 2 times -2 to give you -4. So now I have x times y to the power of 1/3 times y to the power of -4. Y stays the same, and I'm going to add exponents. So I'd add 1/3 plus -4. So for -4, I could write it as -12/3 to have a common denominator. 1 plus -12 is -11. So this is -11/3. Now, in some classes, you can just write your answer as xy to the power of -11/3. But in most Algebra 1 classes, your teacher is going to want you to simplify, and they're specifically going to tell you that they don't want any negative exponents, and they also don't want any fractional exponents in the denominator. So what's going to happen is, if I go ahead and get rid of this negative, I'm going to do so by writing x over, I'm going to drag this into the denominator, and I'm going to make this positive. So this would be 11/3. But now I have a fractional exponent in the denominator. And just like when we saw a radical in the denominator, we took an extra step to rationalize, we're going to do the same thing here. So I want you just to do it with this in fractional exponent form. I don't want you to convert it into having a radical and trying to figure it out that way. Just go ahead and think about what is the next largest whole number that I can get this to. Well, 11/3 is close to 4, but it's not exactly 4, right? It's going to be between 3 and 4. So I've got to get this to 4. So what can we do to get 11/3 up to the number 4? Well, we could add 1/3, right? 11/3 plus 1/3 is going to be 12/3, and that's 4. But we can't just go through and add. What we have to do is use a little trick. Remember, if we use our product rule for exponents, it tells us if we have the same base, right, we're going to add exponents. So if I multiply this by y raised to the power of 1/3, what's going to happen is when I multiply here, the y would stay the same, and I would add exponents. So 11/3 plus 1/3 is 12/3. And in a second, I'm going to write that as 4. Now, I can't just do this. I have to do the same thing to the numerator, right? Otherwise, it's not legal. So I'd write y to the power of 1/3 up here. And so my numerator becomes x y to the power of 1/3. And so to completely finish this off, I'm going to write x y to the power of 1/3 over y to the 4th power. And again, this is just an extra step that we take kind of in Algebra 1, Algebra 2, just to report the answer as simplified. Once you get to higher math, it becomes, less of a big deal. Hello and welcome to Algebra 1 Test Section 5 on using rational numbers as exponents. All right, let's take a look at, we have x to the power of 3/2 times z to the power of -1 times y to the power of -1 times z to the power of 3/2. This is all raised to the 5/4 power. And then this is over y times x to the power of 3/2. So let's start out by using the power to power rule to simplify this numerator. So I would have x that stays the same, and I would multiply 3/2 times 5/4. So 3/2 times 5/4. So what would that give me? Well, nothing would cancel. So 3 times 5 is 15 over 2 times 4, which is 8. So 15/8. Now, with z, I have two of them. I have z to the power of -1 and I have z to the power of 3/2. I could simplify first, or I could simplify after. Let's just simplify after and say we have z to the power of -1 times 5/4, which would be -5/4. And then times y. We have -1 as the exponent there. Again, you'd multiply the exponents, so -1 times 5/4 would be -5/4. And then times z, we have 3/2 times 5/4. So 3/2 times 5/4. 3 times 5 is 15 over 2 times 4, which is 8. Okay. Now this is going to be over y times x to the power of 3/2. In the numerator, if I continue, as I just told you, you have two z's there. So you have z to the power of -5/4, and you have z to the power of 15/8. So let me do z to the power of -5/4 plus 15/8. What I do here is multiply this by 2 over 2, and I'd have -10/8. So -10/8. So -10 plus 15 is 5, so this would be z to the power of 5/8. Then the rest, we'd have x to the power of 15/8, and we would have y to the power of -5/4. Okay, then this is all over y times x to the power of 3/2. All right, scroll down a little bit. So what can we do? Well, I know that if I have x and I have x, I can simplify. X to the power of 15/8 over x to the power of 3/2. That's x to the power of 15/8 minus 3/2. Multiply this by 4 over 4, and I would get what? 15/8 minus 12/8. So minus 12/8. So this would end up being x to the power of 3/8. Now we have z to the power of 5/8. Nothing I can really do with that. And then lastly, we have y to the power of -5/4. And we have a y in the denominator. So let's simplify that. So we'd have y to the power of -5/4 minus, this is basically an understood exponent over 1. Let's write it as 4 over 4. So this would be y to the power of -9/4. Now, of course, we don't want to leave it like that. I would drag y into the denominator, and I would make -9/4 positive 9/4. For some teachers, you can report your answer this way, and especially in higher math, nobody's really going to care. But for right now in Algebra 1, we want to stick to not having any fractional exponents in our denominator. So let's go ahead and think about what we need to do to eliminate this fractional exponent. Well, 9/4 is a little bit more than 2, but it's not quite 3. So the next whole number would be a 3. If I divided what by 4, I'd get 3. Well, 12. So how could I get this to be a 12? What would I do? Well, I'd multiply by y raised to the power of 3/4, right? So let's just kind of drag this over here. Let's say we have x to the power of 3/8 times z to the power of 5/8 over y to the power of 9/4. And I'm not going to do anything illegal here. I'm going to multiply the numerator and denominator by y raised to the power of 3/4. And again, the reason I'm doing that is so that I don't have a fractional exponent in my denominator. So in the numerator, I'll have x to the 3/8 power times z to the power of 5/8 times y to the power of 3/4. And then this will be over. In the denominator, we have y raised to the power of, I would add exponents here. So I have a common denominator of 4, and I would just add 9 plus 3, which is 12. You'd have 12 over 4, which is 3. This would be y cubed down here. So we'd have x to the power of 3/8, z to the power of 5/8, y to the power of 3/4 over y cubed. And again, I just took that extra step, just like when we reported an answer where we had a radical in the denominator, we took an extra step to rationalize the denominator and get that out of there. Although that's not necessary in very high levels of math, right, you can just leave it, it's not a big deal. Particularly in lower level math classes like Algebra 1 and Algebra 2, things like this, we're expected to rationalize the denominator. We're expected to, in most cases, not report an answer where the denominator has fractional exponents. Although some teachers will probably let that slide and not even ask you for it, at least you know how to do it. So this answer right here is mathematically the same as this answer right here, right? They're the same value. All I did was I got rid of the fractional exponents in the denominator.